that would say, hey, given some usage patterns, here's what your leakage model looks like.
That's going to show them what they're leaking, and so then they can act on that data. Now
And that's the big challenge we have as we're looking at these privacy-centric technologies.
Welcome to another episode of the Tech Transfer Podcast. I'm Dave Brown, and I'm here with Professor Casey Deccio from the Computer Science Department. We're talking about a DNS leaking technology. So can you tell us what that is and what problem you've been addressing?
Yeah, since the beginning of the DNS, really, there is, and which dates back to, by the way, early 1980s, there's this idea that any sort of internet communications that we do here on campus or on some sort of enterprise network, some fraction of those queries are getting out to the internet, which is by design. But with an increased focus on privacy in a lot of the engineering groups that sort of design the internet, there's been a mind to sort of minimize the leakage, and so there have been some technologies that sort of address that. But what this paper does is take a step back and take a fundamental view of what it looks like in terms of actual quantity of queries that are going out based on, and when I say queries, I'm just talking about communications that leave your network that sort of give some idea of what your space looks like, what your internet activity looks like.
So if I'm a hospital, and so I have all these patient records, and I have some in the cloud management system that I'm sending data back and forth to, what might I be leaking, and how would someone see that?
Yeah, great question. And to be clear, this actually has less to do with actual content of things you're doing. For just to step back and give you a quick example, you know, if I'm looking at Google and saying, hey, well, I'm doing lookups on certain things, that would be what I consider content, and it's not related to that content per se. It's what happens before you even go do that. So there are certain lookups that we call DNS lookups, domain name system lookups, which happen before you do that, which is the translation of a name to an internet address, which would allow us to even communicate with Google and do those lookups. And so this all happens before that. Now, so going back to your hospital example, a lot of this wouldn't be none of this would be the actual content you're looking at, but it would be sort of the locations that you're looking at, the places that you're communicating with. And if that's a cloud provider, that's actually pretty generic. So maybe a hospital isn't a great example for the diversity that you might see per se, although there might be some aspects that you'd still see there. But anyway, I just wanted to address that it's sort of what happens before that content.
Mm-hmm. So imagine a bad actor who's going to try to view data that you're leaking. What might they be after? How might that hurt an organization? Yeah,
good question. And I guess I'd classify these not necessarily. I mean, there certainly may be some bad actors out there, and so if you sort of drill down into this, you might see some of that. I'd say this is maybe the bigger case is more about having that activity out in the open, and when I say the open, I mean it's sort of like designated parties out there that have to play a role in this translation process, name to address, but they're sort of indirect parties, and they get a little bit more of what your enterprise is involved in through this leakage than what you may even realize. And so going back to your question about bad actors, it's more about minimizing what you're doing and who sees it than necessarily bad actors, although there might be some out there. And then they might turn around and I wouldn't say that they'd maybe disclose it, but they could use it to maybe covertly understand your organization better, or use it for targeted marketing or other monetization practices like that.
So, for example, one case could be, say you're running a hedge fund and there's some intermediary seeing data that you leak. They might know what companies you're interested in. Would that be a reasonable case?
Potentially. Potentially. There could be some aspect of that. Again, if it goes back to the idea that your leakage involves websites you're going to, and again, not the content, but maybe the names associated with those websites, then they could potentially see some fraction of that activity. Parties that maybe you didn't intend for them to see that, but they would know.
Okay. And so what corporations or users do you think would be most interested in this sort of solution?
Yeah, it's a great question. And by the way, a lot of the technology that we've developed is all about better understanding what we are leaking in general. And so it even goes, I mentioned earlier some of the technologies. The big one is what we call query name minimization, which is a standard in the Internet Engineering Task Force. That's the group that determines all these technologies and how they get implemented across the internet. So with this these privacy technologies, we can better understand what they're doing, what they don't do, and sort of what the scope is that's of things that are being leaked out here. And now going back to your question about who might benefit from this, I think anyone with a sort of privacy conscious mind to better understand what they might be leaking, and there might be certain knobs that could be tweaked to better understand that, or hiring of other professional services to better analyze that, or frankly just different practices that they might take to address that, and some of those, like I said, have been introduced into technologies that are out there. But others, there might be additional findings that say, oh, we may want to address this certain thing.
So if a corporation is concerned about leakage and they use your software, my understanding, that's going to show them what they're leaking, and so then they can act on that data. Now they're informed about how big the problem is.
Yeah, and actually, so to be clear, we don't have sort of a product at this point. Yeah. It's a work in progress to better understand how this might be modeled. So it could be a potential product of that people could potentially use to better understand what their usage footprint looks like, if you will, and leakage footprint, and so they could potentially use this model to better understand. But that's the right idea. Is that we have a sort of a generic model that would say, hey, given some usage patterns, here's what your leakage model looks like, and then you could potentially apply that to different enterprises as you suggested.
And your solution involves query name minimization. And from my basic understanding of that, you're changing the name of different domains that you would send queries to so that they're less visible. Is that how it works, or?
So it's not as much about changing the name. It's more about better understanding what what gets leaked based on what your usage is. And now let me be clear that this is more about understanding what your current leakage looks like, and then understanding what query name minimization, which is sort of a solution technology. We didn't come up with that. This is more of analyzing what it helps with, what it doesn't help with, and then sort of next steps would be a strategic look at it. Do you need to change something to improve that if you're not satisfied with what your leakage footprint looks like?
Okay. So what are people doing now prior to your research? What are they doing to identify leakage, and how is your approach different? Yeah,
it's a great question. I'm not sure that I'm not sure if anyone's looking at leakage at this point. I mean, as I mentioned in the beginning, it's not like this leakage was something that hasn't been around. This has been around since the beginning. A lot of people just sort of take it for granted. So the idea that we're looking at quantifying this leakage, that's the novelty of what we're doing, where I'm not sure it's been done before, and actually seeing how well our current solutions actually handling this, and and sort of what's even the trade-off of cost-benefit analysis of doing this. But asking what are people doing now, my guess is they're not doing that much to analyze their own sort of exposure, if you will, which is part of the reason we're doing it.
And what would you expect different organizations to have, like roughly the same levels of leakage, or will there be a lot of diversity?
That's a great question. And let me answer that by saying it's really hard to get data to better understand this. In fact, my guess is, if somebody's interested in this, it really would say it's really a matter of them sort of taking this model and applying it with data from their own network, because it's not something we can do without data from their network. Even us applying it, we've had to be very careful about using our own data to better understand what our footprint looks like here at BYU. Not from us, it was more of like, can we apply this model? It was less about privacy concerns per se, and it was more about can we actually test this out? But because it involves data from actual machines in the enterprise on campus in our case, there's extra sensitivities that need to be taken care of so that it doesn't look like we're exposing anyone's privacy. So everything that we have, for example, is anonymous. We don't know which laptops anything has come from. Getting back to your question about how others might apply it, it would really be a matter of working in their a data set that really comes from their own organization.
Okay, so it sounds like you have research code right now, but someone could potentially, a startup could develop that into a commercial product, and then it would need to be run from inside of an organization to detect their leakage.
Exactly. Right? Yeah, that's a great summary of what needs to be done in the future if it were to be used by other individuals.
And for a large organization like a university, for example, can you run it on one machine and get the whole picture, or would you have to run it all over campus?
Yeah, that's a complicated question. It really depends on the architecture, if you will, of the network of that organization. My guess is that most organizations today are probably situated in such a way that you could collect that data somewhat easily. Okay. But as you mentioned, we're sort of in the code is in research state right now, which means we want it to work and reliably, but it's really made to fit our specific use case of can we do proof of concept analysis and apply our model, as opposed to could we have somebody apply it on their own network per se.
Okay, and I've been thinking about which organizations would benefit most from this. It seems like some organizations like medical and financial are heavily regulated, and leakage could be a problem for them. Are there any other sweet spots you've thought of industries that might be interested?
Probably government.
Oh yeah.
I would guess that might be another one where there could be some concern of surveillance or something like that. Anyone with particularly privacy-centric thoughts about their network activity.
Okay. And could you release an off-the-shelf version of this product, or is this very unique for each organization that uses it?
I mean, I'm a believer that you could really you could create software to be off the shelf for just about anything, but it really depends on. There's a lot of work that would have to happen between now and that point, I guess.
Yeah, sure. And so imagine that work's been done. There's a commercial product, some company's using it, and they'll detect their level of DNS leakage. At that point, is there a lot they can do to reduce the leakage? Like, how actionable is the information? Yeah,
that's a great question. At this point, there's a lot of work that needs to be done in the meantime, to better understand the model and how levels of quote unquote satisfaction with regard to what the leakage looks like and what existing solutions look like for the enterprise that's actually running that software or doing the analysis. And so there's a few steps that need to happen in the meantime to better understand that. And just to give you a little bit of background of where my space is, my research involves, in general, studying the internet and then making, recommendations based on what we find to better improve the internet by way of security, privacy, robustness, and so forth. And this isn't, of course, just my field. This is there's a greater field, but that's the field, the space that I work in. And so a lot of what we're seeing in this particular technology is, there's some room to grow in terms of here's the find out part of things. Can we better understand what it looks like now? The suggestion phase is sort of ongoing, and there's some path forward in that.
And whether it can be easily remediated or not. You could see, for example, the federal government, they could impose requirements and say, contractors to work with us, your leakage needs to be below this threshold or something, and this would give them a way to test it maybe.
Yeah, perhaps. There's certainly some work that would need to go into that. Going back to the sort of more fundamental point that there's going to be some leakage almost no matter what. And so determining what sorts of leakage actually matters is something that that could be looked at further and what that looks like. And it could be that existing solutions like QNAM minimization actually handle that fairly well, perhaps. But it turns out there's one of the things about the internet is that when you put out different what we call specifications or protocols, they basically say, hey, here's the way it's supposed to go, but then implementers go out and actually implement it, and implementation often differs a little bit from developer to developer, and so you do have some differences out there in terms of what that means, and we're sort of still finding out implications of what things look like with this particular analysis that we're doing. And so I guess I don't want to say anything particularly definitive. Most of this is about the fact that we've been able to come up with technology that can effectively provide a decent estimate about what your leakage looks like and how much benefit you might get from QNAM minimization or a different technology, or if you need something additional.
Okay. Well, this could be interesting to entrepreneurs because it's kind of, since no one else is doing the exact same thing, it's kind of a little 0 to 1 opportunity where it's a brand new field, potentially very valuable to people. So if an entrepreneur were interested in launching a startup company and commercializing this, developing a commercial product, what do you see as kind of the obstacles to implementation?
Yeah, that's a great question. I think part of the thing right now is that it's still very developmental. And when I say developmental, both in terms of actual software, I mean defining what that looks like so far. That's one of the things that needs to mature, as well as the implications. I think there's a lot of folks out on the internet that want to have a product out there and would use persuasions that maybe rely on some fear and uncertainty and doubt.
Right.
And I would getting back to this, I would really want to make sure that there's a clear understanding of what value added there is. And there certainly is value to some organizations to better understand what their leakage looks like and what it might look like. But painting a realistic picture for them without delving into the realm, that's sort of a typical quandary of those that are want to be entrepreneurial, want to have a commercial product, but want to be realistic with their customers about what value is added. And like I said, I think there is value painting the appropriate picture of what that looks like, both for the commercial company and for the potential customers. Is I think the tricky part and something that still needs to be sort of filled in. Yeah,
there are definitely some sensationalist sort of products out there making promises that can't be quite right and trying to scare people a little bit. So this would be like a more legitimate high-end solution that institutions could trust. In terms of actually coding, actual development, how challenging do you think that would be?
It's a great question. I think taking things from very much proof of concept, research-based products really would involve better understanding the landscape. When I say the landscape, I'm talking about what data looks like in other institutions. Mm-hmm. What's a typical way that you might actually ingest that data so that you can better process it and analyze it. And then the other piece of it is putting it together into a usable interface. And it would take certainly working with customers, with engineers, and people can interpret that data. You can go to the basic color coding model of, greenish is good and reddish is bad. Right. And that's fine, but this is a fairly nuanced, system that we're looking at. And so, to answer your question, what does this look like putting it together software-wise? I think the nuts and bolts parts are there that can be sort of put together to make a feasible product for maybe people that are on the ground and really understand networks, but making it a more robust product for those that are either not directly familiar with technology. That would take a little bit more time and would obviously require some time working with those that are looking at it and need to sort of read it to the higher ups or whoever makes decisions.
Yeah, so this is kind of the problem that genetic testing ran into. 23andMe and companies like that, they could give very precise answers, but they ran into the problem of, will consumers overread this or think it means more or something different than it actually does? So yeah, part of the challenge for a startup, it seems, would be deciding, are you speaking to technical experts who will understand this? Or is this going to be a tool that the CFO uses to decide, and how do you make it understandable? Is that fair?
Right.
Okay, well, good. And in terms of monetization opportunities, have you had, you speak with other researchers, people in the industry, has anyone said, oh yeah, my organization wants to pay for that, or are we early for that sort of validation?
Pretty early. Yeah,
Okay.
it's pretty hard to tell, if someone might want to pay for this or not. And certainly in the academic community, we put things out in terms of papers so everyone can see
Right.
what this is. If we just feel like this might also be something that others might like to use within their organization and have some sort of an implementation and a product that they would like to pay for. That could be the commercialization route that goes along with it. But certainly it starts out with sort of this idea of anyone being able to see it and see what benefits there are.
Absolutely. Yeah, basic research. And in your research, do you have students who have worked with this in the lab too, or what does that look like?
Yeah. In general, I have students that work with me both at the undergraduate and at the graduate level. I've had students from both levels working on this particular project over the last few years, and as they've sort of come and gone, graduated, moved on, everyone, a handful of them have touched this particular project.
Okay, fantastic. And I asked the question because many entrepreneurs will want to know, are there other technical people who could be advisors or might be interested? So that's great to have that resource. And then finally, Casey, what do you see as future developments? I know you're in the thick of this project right now, but so if you solve this, whether it's commercial or not, like what's next?
Speaking specifically to this technology or in general?
In this area, like in your line of research, to the extent you're comfortable saying.
Yeah, we actually have several different projects going on right now with regard to better understanding deployment of several of these DNS privacy related technologies, and looking at sort of internet scale in terms of who's using them, what impact they have on better understanding the internet. Something I didn't say earlier that part of the implications of using these technologies that are out there that enhance privacy, so to speak, that help address the privacy issue, is that they also at the same time can potentially take away from the telemetry that we use to better understand the internet, which is general users, bad actors, robustness issues, misconfigurations, all sorts of things that we might see at internet scale. And so when we look at these technologies and who's deploying them, we also at the same time try and look at if there are drawbacks to particular technologies, even though they might look really beneficial in some senses, what the sort of cost-benefit analysis is. And so that's part of what we're doing with this particular technology that we talked about today, but also with better understanding other technologies that are out there.
Okay, fantastic. Over your career, like we are where we are in the history of the internet, do you think things have improved in terms of privacy, or is it getting worse or better?
Yeah, that's a great question. And that one even is a little bit hard to answer for the very reasons that I just mentioned. And that is because the more we try and make things less visible to third parties what we're doing, or even to the parties we're directly communicating with, there are huge benefits to that for those that are especially concerned about disclosure of any form. But that means that bad actors can also take advantage of that.
Right.
And that makes it much harder to detect at the enterprise level, at the internet level, et cetera. And so it's sort of like a two-edged sword to some extent. We've seen that with different technologies, like our going back to encryption. We can't see anymore. Just our communication between us and a given server out there because of encrypted channel, which is great. And I think no one disagrees with that. But that means the bad actors out there can basically do the same exact technology. And so how can we be sort of smart enough to apply these privacy-centric technologies in such a way that the general population benefits, but we can still identify bad users or bad actors out there, and how to protect all the rest of the users on the internet. And that's the big challenge we have as we're looking at these privacy-centric technologies.
Okay, fantastic. Well, your technology, the DNS leaking detection, just gives people more information. That seems like it has to be a net positive. Whatever decision you're trying to make or whatever you're trying to do with privacy, it's got to be better to know what you're doing. So thanks for taking the time to explain it to us, Casey. It's exciting research, and hopefully we can get out there where it helps people.
Yeah, I appreciate that. Thanks so much for having me.